Hey guys, this is lesson 8-2. We are continuing our chat about data today. The lesson today is going to be about dot plots and something called histograms. So we are looking at more types of graphs. So this first page says the data below shows the number of hours a group of students spent doing homework last week. Here's all the hours of homework that they did. It says draw a dot plot to represent the data. Title your display. Okay, so a dot plot, remember, is a line going like this. And you need to have all the data points represented on your dot plot. So I'm going to start with 0, and what's the highest one on here? It looks like 8 is the highest. So 1, 2, 3, 4, 5, 6, 7, 8. And then I need to go ahead and plot it. So I'm going to mark off my data as I'm doing it. So 5 gets a dot. 4, 1, 6. Remember, as I'm doing these, this is the number of hours kids spend doing their homework. So 0, a kid spent 0 hours doing their homework. Another kid spent 5 hours doing their homework. So 5 has 2 dots now. 3, 3, 5. So I got 3, 3, and another one for 5. 6, 1, 3. 6, 1, 3. 8, 5, 4. So 8, 5, and 4. All right, so here's all the hours that kids spent doing their homework, and it says we also need to give a title. So I'm going to title this Hours Spent Doing Homework Now, this would be important. Is it each day, each month, each year? It says hours of a group of students they spent doing homework last week. So hours spent doing homework last week. That's an important piece of information. Okay, so now that we have our dot plot, we can start answering some questions. First, how many students does your dot plot represent? Explain how you know. Okay, well, I can just count the number of dots, because each dot represents a student. So how many kids is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this represents 15 students. Analyze. Why are no dots shown at 2 and 7? That's true. There's no dots on top of the 2 and no dots on top of the 7. There were no kids who spent 2 or 7 hours doing homework. So that just means kids spent 0 hours doing homework, 1 hour doing homework, 3 hours doing homework, but nobody spent 2 hours doing homework. And the same goes for 7 hours. Number 4. Why do you think 5 hours is the most frequent number of hours? And explain. Okay, well, I mean, this one's a little bit tricky because we don't really know why 5 is the most popular. Maybe we could say maybe many kids spend 1 hour a day doing their homework. So Monday, Tuesday, Wednesday, Thursday, Friday, maybe that's popular. Could also say that 5 is kind of in the middle. Not exactly in the middle, but it's kind of in the middle of the data set, which was 0 to 8 hours. So 5 is kind of in like that middle area there. So maybe that's why a lot of kids did it for 5 hours, because 0 was the lowest, 8 was the most, and so it's kind of clustered in the middle there. All right, so number 5 says the data represents 15 students. Would the scale of the plot change if it included more students? The scale of the plot, what that means is, would this extend out past 8? Would it go to 10, 15, 20 hours if we had more than 15 students? So it's possible. The more students you had, you could have a scale that goes out to 10, 15, or 20 or way more hours than 8, but it's not likely. The only way that would happen is if one kid or a couple kids did tons and tons of homework. But we could just say not likely, because most students probably spend 0 to 8 hours doing homework. Doesn't matter how many kids you ask. You could ask 1,000 kids instead of just 15. 1,000 kids would probably have last week spent 0 to 8 hours doing their homework. Now the dots would be way higher if you had 1,000, because instead of 15 dots here, you would have 1,000 of them. But your scale on the bottom of how many hours they spent, that would not likely change. The only way that it would change, like we said before, is if out of those 1,000 kids, maybe some of them spent more than 8 hours. Maybe they spent 9 or 15 or 20 hours doing their work, but most of the data would still probably be here between 0 and 8. All right, next it says, suppose the data represents 6th grade students. Would the data change if it represented high school students? So they're saying, what if all 15 of these kids are 6th graders? Do you think this would look different if it was high school students? I would say probably. And why? Because high schoolers usually have a lot more work. Right? So what you have in 6th grade, whatever amount you're doing now, it's way more homework when you're in high school, right? So if the average 6th grader spends between 0 and 8 hours on homework last week, for high school, those numbers would probably be a lot more. It would probably be, the scale might be 0. You might still have some high schoolers that do nothing, but I would bet that some of them spend like 16 or more hours. It probably doubles when you're in high school. You spend a lot more work. So yes, I think our data would change for high schoolers. All right, so we got some Puzzle Penguin going on here. First, we have Puzzle Penguin talking about this graph, the number of bows on the tails of kites. So we're looking at if this is a kite, and then someone's holding on it in the wind, right? It's a windy day and it's fun to go outside. The bows mean these. So there's 1 bow, there's 2 bows, 3 bows, okay? So those are bows. That's what they're talking about. Okay, so dear math students, the dot plot at the right displays data about kites that were seen at the beach. I interpreted the dot plot to show that 2 kites had tails with 5 bows on each tail. So 2 kites, 5 bows on each tail. And 4 kites had tails with 1 bow on each tail. 4 kites had 1 bow. Did I interpret the dot plot correctly? No, Puzzle Penguin. What it is showing, it's not showing that there were 2 kites and they had 5 bows. What it's showing is that there were 5 kites with 2 bows. Okay, so there were 5 kites, the number of bows on tails on each kite. That means right here, this right here is the number of bows. Okay, so there's 2 bows. That was on 5 different kites that he saw that. So there's 5 kites with 2 bows. And the same thing goes with the other one. So also, it shows 1 kite with 4 bows, right? Because this is the number of bows, and the dots are the number of kites. Okay, so you just have to understand how to read the graph. If the title is telling you the number of bows, the title is talking about these down here. Okay, so this is the number of bows. All right, next question. Dear math students, 5 of my friends made a dot plot to show the number of times they ate hot lunch at school last month. My 3 friends, represented by the dots on the left side of the plot, said that altogether they ate hot lunch more times than my 2 friends, represented by the dots on the right side of the plot. Can you help me decide if they're correct? So basically, no, the friends are not correct because Puzzle Peng was always wrong. This time it's his friends who are wrong. But they're saying that the 3 friends on the left side, they're saying that they ate hot lunch more than their friends on this side because they see that their dots are higher. So they're like, we ate hot lunch more than you guys, but that's not true. The number of times they ate hot lunch is right here. So 3 friends ate hot lunch only 2 times. Okay, and then over here, 2 friends, those are the 2 circles, ate hot lunch 6 times. Okay, so basically you have to pay attention to what each thing is talking about. Your title is always talking about the numbers on your line plot. So this is the number of times they ate hot lunch. So they ate hot lunch is down here, 2 times or 6 times. Your circle is the people. Okay, so that's why the friends were wrong, because they said, ooh, we have higher dots here, so we're the winners. We had it more times than you guys. But no, they only had it 2 times, whereas 2 kids had it 6 times. And the question was, who ate hot lunch more times? These guys, because they had it 6 times. All right. Next page says something about a histogram. All right, so a histogram is a frequency display that uses bars to show the distribution of data in a set. The data are presented in intervals. An interval is a range of numbers. So I would explain to you guys that a histogram is a lot like a bar graph, but instead of having one number at the bottom, it's a range of numbers. Okay, so this is population with age, and this is showing that this is ages 14 and under. So this is ages 0 to 14. This is ages 15 to 24, 25 to 34, and all the way up here you have people who are 75 years and older. So it's very similar to a bar graph. It works the same way where you get to read the bar and then go over to your y-axis to see how many it was. Except your bar doesn't represent just one thing. It represents a group of things. In this case, it represents a group of ages. So a histogram and a bar graph are very similar, except a histogram includes a group of data. Okay, so a histogram is used when we want to graphically display a large set of data. The intervals are usually the same size, which means like 14 and under, 15 to 24, 25 to 34, usually they're skip counting by very similar numbers, right? You see 15, 25, 35, 45, 55, 24, 34, 44, 54, 64. The ones that are different are 14 and under, because that's 14 different ages, and this one is 75 over. That could be an infinite number of ages depending on how many people are there. But for the most part, the histogram, each group is representing the same number. Okay, all right. The bars touch, so all the data in the set are included. Height and width are 2 important characteristics of the bars. The vertical height, or the y-axis of the bar, shows the frequency, or the number of times the data value occurs, right? Just like on a bar graph. You're seeing how high it is, then you're going to read the y-axis. The horizontal width shows the intervals into which the data are grouped, right? So how wide this is depends on what your interval is down here. All right, so we're going to answer some questions about this data set. And we have to pay attention to right here. These are on the left side, or on the y-axis. These are skip counting by 10. So some of these are not lined up exactly to a line that's in the background. So we're going to have to kind of estimate somewhere in between that group of 10 what the number is. Okay, so number 9 says, which age group has the which age group has the least number of people? So the least, we're going to look for the shortest bar, and that looks like right here. So the people that are 75 and over, that is the smallest group of people in the US population in the year 2000. Number 10, which age groups have nearly the same, so not exactly the same, but nearly the same numbers of people? Are there two of these that are like almost tied? What do you guys think? I don't know, these two are very close to each other, but this one over here looks kind of close too. Maybe we can have a three-way tie. So we could say ages 15 to 24 and also 25 to 34, the purple one. But I think this one too looks very close to the other one. So we'll put three of them. Those ones are which age groups have nearly the same numbers of people. And how many are in there? I would say they're all right at about that 40. This is in millions, so about 40 million, maybe a little less than that. About 40 million people are aged 25 to 34, maybe a little less than that, maybe 39 million are 15 to 24, and maybe a little less than that, 38 or 37 million are 45 to 54 years old. That's how you read that graph. Number 11, what age group has about 15 million people? Okay, so for this one, I would start right here and I would go, well, where's 15? Here's 10, here's 20, so 15 would be right in between that. Which one of these bars is right at about that level? So I'm going to kind of estimate here. So far it's not these first three groups, it's not this group. Hey, I think I found it. This orange one right here is lined up with about 15 million. So age group 65 to 74 has about 15 million people in it. Number 12, about how many people are 14 and under or 75 and older? Okay, well, let's do 14 and under first. So 14 and under, how many people is that? Looks at maybe a little bit higher than 60 million, because there's the 60 million line and it's right above that. Maybe we could say 62 million or 75 and older. How big are they? Let's see. Well, let's just keep this one going. If this one was 15, right? Well, this one must be, that line that's right below it must be the 10 mark. So I think 75 and older is probably the 10 million mark. So if we put those together, we could estimate about 72 million people. So about 72 million people in the United States in the year 2000 were age 14 and under or 75 or older. Number 13, discuss where do you think a person that's 34 and a half is included in this graph? Okay, so if you're 34 and a half years old, let's figure out where that would be. Oh, so this purple one goes to 34, and this orange one is on age 35. So if you're 34 and a half, where do you think you would go? Because 34 and a half is right in the middle of 34 and 35. I think it would still go in the 25 to 34 category. That kind of got messed up. It should be 25 like this. Because if you're 34 and a half, when somebody asks you how old you are, you'd still say you're 34. You don't say you're 35 yet. So even though you're 34 and a half, you're technically not 35. So I don't think you would be in this orange category. I think you would still be in this purple one. Good question though, if you're in that halfway point. Okay. So this is our last page for the lesson. And it says we're going to make a histogram. So remember, a histogram is what this was when you have different chunks of numbers, kind of looking like a bar graph. And this table below shows the lengths of various U.S. rivers, so how long these rivers are in the United States. So we have all these different rivers, and then it tells us all these different lengths in miles. So on the grid below, we get to draw and label a histogram of all of this data. Okay, well, I know that we always have to have a title, so I should start out with that. And I can pretty much use the same title that they gave us here. I'm going to call it Selected Rivers of the U.S. Okay, so then, let's see. If we go like this, we need to figure out our scale. I'm going to use my X and Y axis right here, just the left side of the grid and then the bottom side of my grid. And I need to come up with miles. So my scale for miles, I think the smallest one is 0. Well, 0 doesn't exist, but my smallest one, let's see, 45, 90, 97 is going to be 45. So we'll start at maybe 1. So maybe the smallest one can be 0 to how big? Well, maybe let's do, what is our biggest thing here? 407, 410. Our biggest one is a little over 400. So maybe if I think this is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's perfect. So we'll do 0 to 100. Could be this first bracket right here. And then we can do 101 to 200. And then we can do 201 to 300. And then we could do 301 to 400. And then 401 to 500. So this will capture all of the lengths in miles of the rivers. So we need to label this axis. So the lengths in miles of all these rivers. So what would be on this axis then? If this is the lengths in miles of the rivers and we have different numbers there, I think that on this side it would be how many rivers are like that. So we could say number of rivers. And looking at my scale here, I have 1, 2, 3, 4, 5, 6, 7. So I double that. There's 12 rivers here. I'd probably be safe to just do a scale of 1 and say 0, 1, 2, 3, 4, 5, 6. Because even though there's 12 rivers, I don't think that we're going to have 12 be one of our answers, because that would mean we had 12 rivers that were all in the same category. And I don't think that's true. So let's fill this out. How many rivers are between 0 and 100? Let's make this first one red. So between 0 and 100. This one, that's between 0 and 100. And this one, so there's 3 that are between 0 and 100. So I'm going to make this first one go all the way up to 3. Okay. Now my next one would be between 101 and 200. So this one, so just 2. Okay. So between 101 and 200, there's 2 different rivers that meet that criteria. Between 201 and 300. Okay. So 1, 2, 3. Okay, so 3 rivers meet that criteria for being between 201 and 300 miles long. How many rivers are between 301 and 400 miles long? 1, 2, 3, 4. Okay, 4 rivers are that big. So this next category between 301 and 400 goes all the way up to 4. There's 4 different rivers. 1, 2, 3, 4. And then how many rivers are between 401 and 500 miles long? 1, 2. So my last category is going to go up to 2 because there's 2 rivers that were between 401 and 500 miles long. And I know I captured all my data because I was color coding it as I went. All right, so you guys, that is it for lesson 2. It was kind of just exploring what are histograms, what do they look like, and then analyzing some data for some dot plots. All right, that is it. We'll catch you at the next lesson.